In this video, we're continuing topic 8.2, and we're going to talk about example 11. Before we get into example 11, we're going to go ahead and look at this left-hand column here. So two concepts that are in this left-hand column are the speed of a particle and the total distance of a particle. Well, the speed of a particle we actually learned earlier in the year, and it is the absolute value of the velocity of the particle. The total distance of the particle is the integral from A to B, whatever that is, of the absolute value of the velocity of the particle. So let's talk a second about that. If I am just going to integrate without the absolute value, that's going to give me what we call displacement. But with the absolute value is going to give me the total distance covered. So let me show you an example. So if I have a particle, it goes and it turns around a little bit. So what the displacement would get me is from point A to point B. It would just get me that distance right there. But what the absolute value does is it gets this distance. It also includes this distance in here where it went negative, and then this distance here. So that would be the total distance that it traveled. So that's why we use it. When we use the absolute value, that's what we're getting. All right, so let's look at example 11. So it says we want to find the speed of the particle. Ooh, it starts us with position. X of t equals sine t. It gives us a value. So let's actually stop there and do that one. So it's because it says find the speed. So that's really kind of, if we were talking AP test, that would be the first point. So we know that speed is the absolute value of velocity. So I know that if I've got position, in order to get velocity, I'm going to have to take the derivative of it. So that would be cosine of t. And then I need to find the position at pi over 3. And in order to find the speed, actually, I need to take the absolute value of the cosine of pi over 3. Well, we know that the cosine of pi over 3, let's go back to our good old unit circle, out 1 up 0. So it's 1, 2, 3, and then it would come down 1, 2, 3. So it would have to be pi over 3 is right here. The x coordinate is 1/2. So it would be absolute value of 1/2 or just 1/2. So my speed is 1/2. Then it asks us, what is the total distance covered from the initial time to this time? So to this time here that we're given. So to get total distance, we would do the integral from 0 to pi over 3 of the absolute value of the velocity. So the velocity is this. I'm going to do the absolute value of it. Now, in this case, we're going to use our calculator to assist because this is not an easy one to integrate. So we're going to come over here. I'm going to do a shift plus. I'm going to go from 0 to, I'm going to do a control divide. And then we're going to go pi, which is underneath this little pi. Oh, not that, not that, not that, not that. It's going crazy. Sorry. Okay. I'm going to go here. Pi over 3. And because this one's simple, I didn't go into the graph. And then I want absolute value. Absolute value is hiding in the button next to the book. And then it was just cosine of x. Because remember, oh, actually, you know what? In this part, I could use t's because I'm not in the graph. So let's use a t this time. But I have to make sure if I put a t here, I also put a t here. And then hit enter. So 0.866 is where we're at here. Ooh,